The Great Void of the Universe, better known as Boötes Void, is the emptiest space in the known universe. This region of the universe is so large and strangely empty that it is an enigma to scientists. What happens inside this place, and how was it formed? Let's find out. When we look at the night sky, it is a pretty uniform place, right? Although it is not really at all. Specifically, there is a large spherical area near the constellation of Boötes, with an estimated diameter of 250 million light years. The Boötes Void that only keeps about 60 galaxies. So from a practical point of view, and considering the dimensions of the universe, this place is practically empty. Do not confuse voids with black holes. Black holes are vast and massive celestial bodies that result from a star's death. These have an immense force of gravitational attraction and are the densest objects in the universe. Voids, on the other hand, are just that, almost empty areas of the universe where there seems to be nothing. An inexplicably empty space. The Boötes Void was discovered by astronomers Robert Kirshner, Paul Schechter, Augustus Oemler Jr., and Stephen Schechtmannen of the University of Michigan in the United States in 1981. Approximately 700 million light years from Earth, and is located in the vicinity of the constellation of Boötes, hence its name. Researchers came across this mysterious cosmic location during a study of galactic redshifts. Redshift is a way to measure the distance at which galaxies are. A redshift can occur when a light source moves away from an observer, and blue if it approaches. This occurs due to the Doppler effect that changes the perceived frequency of waves when the emitter moves. Astronomical spectroscopy uses the redshifts of the Doppler effect to determine the motion of distant astronomical objects. So if a galaxy has a red shift, it moves away, but if it has a blue shift, it gets closer. Because our universe is expanding, the farther away a galaxy is, the faster it moves, meaning the redshift can be used to measure how far away it is. Kirshner and his team leveraged this to create a 3D map of the universe. That's when they noticed something strange. A blank void in which there should be thousands of galaxies. It was initially called the Great Nothing, but was soon discovered to contain some small galaxies. Not so void. Despite the name, the Boötes Void is not empty. When scientists discovered this mysterious place, we immediately pointed out our telescopes to study it thoroughly and unravel all its mysteries. Thanks to them, the first thing that was discovered was that inside it had galaxies. But these galaxies were different from the ones we know. In the universe, galaxies tend to cluster in galaxy clusters several thousands or even millions of light years away. But galaxies within the Boötes vacuum were alone. While at the edges of the void, galaxies tend to cluster or are close together with each other, like galaxies orbiting the Milky Way. In total, about 60 galaxies have been discovered in the vast space encompassing the Boötes Void, which is extremely strange considering that there should be at least 2,000 galaxies in a space like this. These discoveries raised new questions about voids, such as why galaxies are alone with nothing else around them, or why are some galaxies attracted to voids and others are not? It's a mystery. How big is the Boötes Void? This region covers 250 million light years in diameter, even though it only contains a few dozen scattered galaxies in the shape of a rough tube that passes right in the middle. It is so large that its diameter is 2% of the diameter of the observable universe. To get a more graphic idea, our Milky Way galaxy could easily fit inside the void along with the Andromeda galaxy, and there would still be plenty of space. It was one of the first large voids discovered, and due to its size, this area is usually referred to as a supervoid. It is currently known that the Boötes Void is the most lonely in the universe. Although it contains up to 60 galaxies, this is nothing if we consider that these are mainly small galaxies and that there should be thousands of galaxies in a common region of the universe with that dimension. It seems as if galaxies have left this region for some hitherto inexplicable reason. Origin. The structure of cosmic space, seen from a panorama, consists of a series of networks and filaments of regular matter and dark matter. The latter is an overwhelming 80% and interacts gravitationally with conventional matter. This is how astronomers can detect it. But between these filaments and spirals, we can find cosmic voids, which are very thin and have different sizes. Even so, its characteristics are invariable. Within a void, there may in turn be another void, creating a nest-like structure. Experts believe that these vacuous bubbles contain the clues that will lead us to understand some enigmas of the universe, such as the nature of dark matter and dark energy, that force accelerating cosmic expansion more and more. One possible explanation for the Great Boötes Void is that it was formed from the merger of smaller voids. This explanation is because galaxies appear gathered in tubular form as if they have been grouped relatively recently. The Boötes vacuum intrigues scientists mainly because it is not known exactly how it formed or how it will evolve shortly, since it seems that galaxies are moving away from it. Another cause of this emptiness lies in the origin of the universe. In the early days of the cosmos, all matter in the universe was very tight. Initially, it was thought to be a uniform soup, but random quantum fluctuations soon created slight differences in the distribution of matter. Some areas were now a bit denser, meaning their gravitational pull was more incredible, so they moved matter away from less dense areas. This made them even denser, increasing their gravitational pull again so that they attracted more matter and so on. At the same time, the universe was expanding enormously, so these fluctuations that began at the quantum level eventually spanned hundreds of millions of light years. Meanwhile, smaller clumps of matter began to organize into galaxies. By studying these large structures, astronomers can gain a window into what the universe looked like in its earliest moments. Today, advances in imaging technology and telescopes mean they can create more detailed versions of Kirshner's maps, such as the Dark Energy Survey, which mapped a quarter of the southern sky, examining about 300 million galaxies. Meanwhile, supercomputers can now create detailed simulations of how the universe has grown from these moments after the Big Bang to the cosmos we see today. By comparing these maps with simulations, astronomers can understand how our universe came to look the way it does today. Voids filled with dark energy. The voids consist of vast expanses of the universe that contain no galaxies, stars, cosmic dust, or asteroids, essentially as close as we could find to nothingness. Although, as the name implies, the voids are not empty, because in addition to the galaxies we have discussed, they are full of dark energy. Dark energy is a form of energy that would be present throughout the universe, producing a pressure that tends to accelerate the universe's expansion, resulting in a repulsive gravitational force. Considering the existence of dark energy is the most systematic way to explain recent observations that the universe appears to be expanding rapidly over 6 billion years. The cause would be that the density of matter decreases as the universe expands, while the density of dark energy remains constant with expansion. Although dark energy cannot be detected in any way, its existence is the only way to explain the standard model of cosmology, in which dark energy contributes almost 69% of the total energy of the observable universe. Dark energy is known to permeate the entire universe, regardless of whether there is matter. So the Great Boötes Void must also be filled with this invisible and undetectable energy. This mysterious energy that does not interact in any way with matter, but that is present throughout the universe, could be what allows the existence of voids, because if the matter slows the growth of voids, the dark energy makes them grow. It means that the voids will continue to grow with time, thanks to the force provided by all the dark energy. Are there more voids? Of course. It's not the only vacuum. There are others, such as the Eridanus supervacuum or Cold Point CMB, which is much larger, with about 500 million light-years in diameter, and was discovered by microwave waves. Despite being one of the most significant structures in the universe, the Boötes vacuum is better known. There is also the Local Void, another sparsely populated region of about 150 million light-years. Our galaxy lies relatively close to the edge of this void. The center of the Local Void is thought to be at least 75 million light-years from Earth. Do you think that in the future we will find more voids in the universe? Let us know your opinion with your valuable comment.